This is an introduction to kinematics, and kinematics is the study of the motion of a particle. There are three main concepts here: displacement, velocity, and acceleration. Displacement is the distance from the starting point O and is denoted by the letter S. For velocity, velocity is the rate of change of displacement. And how do I get velocity? I just need to differentiate my displacement to get my velocity. For acceleration, acceleration is the rate of change of velocity. So it means I just have to start from velocity and I differentiate one time to get acceleration. There are three other main concepts in this chapter. When they say initial point or there's a keyword initial, it just means that the particle is just starting to move. Just starting to move means my time t is equals to 0. When the question says instantaneous rest means resting at that very instant. And resting means not moving. And when it's not moving, what happens to its velocity? Velocity, which is your speed, would be equals to 0. Lastly, for deceleration, is related to the word acceleration. But it's the opposite of acceleration. If my acceleration is negative 4 meters per second square, then my deceleration is equal to 4 meters per second square. So we just have to take the absolute value of my acceleration. Now we come to a question. Particle P moves in a straight line and passing through fixed point O. Its displacement S is given by this expression, where my S is in terms of t. Now, they want us to find velocity. So, if I'm given displacement, how am I going to find velocity? I need to differentiate one time to get velocity. Differentiate my displacement to get velocity, but now I need to find t equals to 3. So, sub t equals to 3. And we'll find our answer. My answer will be 36, but I need to put my units. Meters per second. Meters per second is the units for velocity. Now come to question 2, when we have to find acceleration. If I found my velocity, how am I able to get my acceleration? Same thing as question 1, I need to differentiate my velocity. I differentiate velocity to get my acceleration, but now I need to find when t equals to 3. So let t equals to 3 and we'll find our answer. Answer is 42, but I need to include my units. Meters per second square. Part 3, they mentioned when P is at instantaneous rest. And remember, when I say about instantaneous rest, what happens to my velocity? It stopped moving, so velocity equals to 0. Letting v equals to 0, I'll get an equation of t. And before I continue, I can simplify the equation, divide both sides by 6 to simplify it. The equation is simple enough to do my factorization before finding my values of t. I have two values, 1.5 and 1, and I can accept both because both are positive numbers, and time is supposed to be positive. But just to emphasize that when I have instantaneous rest, the particles can change direction. So I need to take note that these two time values can allow the particle to change its direction. So if we move on to part 4, they want to find the distance traveled by P in the first 2 seconds of its motion. I need to be careful. I need to write down a few timings. For part 4, I took note of these 4 timings. T equals to 0 is crucial because that is the initial timing. Whereas for T equals to 2, T equals to 2 is the final timing. For my 1 and 1.5, these are the instantaneous rest time. So I can change my direction. Now, letting t or be all these values, I need to find my s for displacement in all these cases. Once I sub in all these values, I can tell that my displacement will be 0, 7, 6.75, and 8 respectively. So now let's draw a diagram to visualize the motion of the particle. First, at t equals to 0, it is over here. Whereas for t equals to 1, it will be at 0.7. So it travels to 7 and stop at t equals to 1. Now at t equals to 1.5, it's in this location. So it U-turns back so that t equals to 1.5, it will be at this position. And lastly, t equals to 2, it will be at number 8. So it U-turns back and goes to 8 at t equals to 2. Now with this pathway of the particle, can we find the total distance? Total distance for this first part would be 7. Next part, when it goes from 7 to 6.75, I just need to add the difference of 7 and 6.75. And for the last part, I need to add the difference between 8 and 6.75. Using a calculator, I can find my total distance traveled, 8.5 meters. Last question, the distance of P from O. You need to recognize that any distance from O is called displacement. So I'm just finding the displacement when t equals to 2. So at t equals to 2, my displacement would just be 8. And hence, from the previous part, I have already found my answer. At t equals to 2, my displacement will be 8 meters. That's the end of the question.